several new notations that you have to get used to when you're looking at statistical formulas and just even in questionings that they can ask you in statistics. Now, some of the basic vocabulary that is something that is important for you to get into your regular vocabulary is when we talk about the difference between a population and a sample. When they talk about a population, they're saying that you have all of the elements of what it is that you're interested in studying for that particular situation. And when we talk about a sample, it is a pull of some of the elements out of that population of interest. So remember, the population is the overall group that you're trying to get information about, either estimating it or making some sort of judgment about it or whatever. And the sample is the few or how many ever you pull out of the population. Now we want to portray the information to another person about whether we've calculated information about a population or whether we've calculated the information about a sample, so that they know actually how the information is in terms of its viability. So when we look at the idea of a population, if I calculate the mean or the standard deviation or the variance or whatever it is out of the population, I have the entire set of data for the entire group that I'm interested in. And so those values calculated will be the same today as they are for tomorrow if I have that specific population. So in that case, those measurements are called parameters because they don't change. If I just pull a few out of a population or some of them out of the population and I calculate the mean for that sample, it may or may not be what the population mean is, because I didn't grab them all, I just grabbed some of them. And then if I go in and grab a different sample from the same population that I did before and calculate the mean won't be exactly the same for the second sample as the first sample. So we call the information that we calculate from a sample of information a statistic, because it's gathered just from a subset of the overall population of data instead of the whole population of data. So those are words to use. Parameter is measurement that you've calculated from the population, and statistics are from the sample. Now, with notation, typically we use Greek letters when we're talking about these measurements about a population, and we use the letters from the English alphabet if we're talking about our statistics that we gathered from a sample. The thing is that there's one situation specifically that is mostly used that we can't or don't choose to use the Greek letter for it. And so on this table, I'm going to show you what those symbols are and the names of them. When we're talking about the mean of our data, we add them up and divide by how many values we have. If it's the mean of the entire population, it's symbolized as the Greek letter mu. If we're talking about the sample mean, the mean that's calculated from a subgroup of our population, then that's denoted with an X and a bar over top of it. So X with a bar over top of it is the sample mean. It's a statistic. Mu is the population mean. It's a parameter. Now the thing is that the formula doesn't change between whether we are calculating the sample mean or the population mean. So usually when they report this, like on the information you would get from your graphing calculator, if you're allowed to use that in the class, then you would look across from the X with a bar over it for the mean. Next up, how about the standard deviation? Well, the standard deviation symbolism from a population parameter is sigma. And it kind of looks like a script O with the top on it. Okay, so that's sigma. And for the sample standard deviation, we use S. Greek letters for the population parameters, English alphabet for the sample statistics. Again, if you're using maybe a graphing calculator, they might go sigma sub x to report to you the population standard deviation, and then S sub x for the sample standard deviation. Just look specifically for whether it's the Greek letter or the English alphabet letter. And they do have a specific difference in the formula for standard deviation of a population as opposed to a sample. So they actually have two different lines that they're reported on that screen. So make sure that you look at the right one appropriate for the question. For variance, well, variance is just the square of the standard deviation. That's how you find it. And so they want to remind you of that. So with the notation for the variance, they take the notation for the standard deviation and show the square on it. So that's the symbolism for the population variance. For the sample variance, it's S with a squared on it. Again, to remind you of how you get that value. Now, the proportion, that's the one that goes a little bit against what the convention was set for the earlier things. See, if we were going to use the Greek letter that closely goes to the letter P, our natural selection would be pi. But when they tried to use that in statistical settings several years back, people were not reading in context for that. It was a parameter of the population proportion, and they were continually making the mistaken assumption that it meant the same thing as the geometry usage when we use pi. So they decided to do with a different convention for symbolism for the population proportion and the sample proportion. So here's where we actually do use a small case p for population proportion, and then we make a p with a hat over it for the sample proportion. And so here are the symbols that you'll see very frequently in your statistics course and what it is that each of those mean.